In the boundless dark waters of the deep sea, where sunlight dares not venture, lies a world as alien and unexplored as the surface of another planet. This enigmatic realm, stretching below depths of 200 meters where the last vestiges of light fade into the abyss, is home to some of the most bizarre and enigmatic creatures on Earth. The journey into these shadowy depths reveals not only the incredible adaptations of life in extreme conditions, but also how much remains unknown in the vast uncharted territories of our own planet. In the immeasurable expanse of the deep sea, a realm of perpetual night unfolds far below the reach of the sun's rays. This vast enigmatic domain, extending below depths where the last whispers of light fade into obscurity, harbors conditions that are among the most extreme on Earth. It is a world shrouded in darkness, where the pressure is crushing, temperatures are near freezing, and life exists in a state of perpetual adaptation to an environment as alien as the surface of another planet. The absence of light has sculpted a landscape unlike any other on our planet. Without sunlight, photosynthesis is an impossibility, setting the stage for an ecosystem that relies on a complex web of detritus falling from above or on the chemical energy harvested from the Earth's crust itself. The immense pressure, over 1,000 times greater than at the surface, and the cold, near-freezing temperatures create a seemingly inhospitable environment. Yet, it is here, in the complete absence of light, that life has found a way to not only survive, but to thrive in astonishing diversity and ingenuity. The deep sea's inhabitants have evolved in isolation, resulting in unique adaptations that seem almost otherworldly. Many species have developed enhanced sensory capabilities to navigate, hunt, and communicate in the eternal night. The lack of visibility has led to the evolution of creatures with highly developed olfactory senses, specialized lateral lines, or acute electroreception, enabling them to detect the slightest movements or electrical fields generated by potential prey or predators. Bioluminescence is perhaps the most striking adaptation found in this shadowy world. Many deep-sea organisms generate their own light through biochemical reactions, creating glows, flashes, and pulses of color for communication, attraction, and defense. This living light show plays a crucial role in the deep sea's ecological dynamics, with creatures like the anglerfish using bioluminescent lures to attract unsuspecting prey into their gaping maws. Furthermore, the extreme conditions have led to remarkable physiological adaptations. Deep-sea creatures often exhibit slow metabolism rates, allowing them to conserve energy in an environment where food is scarce and unpredictable. Their bodies may be gelatinous or highly compressible, enabling them to withstand the immense pressure without damage. Others have evolved minimal skeletal structures to reduce the need for calcium, which is less available in the deep ocean's cold, high-pressure waters. This world shrouded in darkness is a testament to the resilience and adaptability of life. It challenges our perceptions of habitability, showcasing a myriad of life forms that have ingeniously adapted to thrive in conditions that once seemed beyond the realm of possibility for life. The deep sea remains one of the last great unexplored frontiers on Earth, a reminder of the vast unknown that awaits discovery beneath the waves, holding secrets to life's adaptability in the cosmos. In the inky depths of the world's oceans, beyond the reach of the sun's nurturing light, lie environments as alien and imposing as any outer space vista. Here, in these abyssal plains and trench depths, life has taken on forms and sizes that defy imagination, giving rise to what can only be described as the giants and ghosts of the deep sea. These creatures, some of the largest and most ethereal beings on Earth, inhabit a world of perpetual darkness, surviving under conditions that would be lethal to most other forms of life. The giants of the deep sea are creatures of mythic proportions, embodying the true meaning of monster in both size and mystery. Among them, the colossal squid stands as a testament to the unexplored and unknown depths of the ocean. These leviathans, with tentacles rumored to reach up to 14 meters or more than just fodder for sailors' tales. They are real, albeit rarely seen, inhabitants of the deep. Encounters with these creatures are usually accidental, often involving a battle-scarred sperm whale or a dead specimen washing ashore, leaving scientists and enthusiasts alike in awe of their size and the potential for what else lurks in the unexplored darkness. Equally fascinating, though less colossal, are the giant tube worms, which thrive in the extreme environment of hydrothermal vents. These vents, spewing mineral-rich water heated to boiling by the Earth's magma, are oases of life in the deep sea. The giant tube worms, reaching lengths of several meters, have no digestive tract. Instead, they rely on symbiotic bacteria living within them to process the sulfur from the vent's emissions into organic molecules, a process akin to photosynthesis, but powered by chemical energy from the Earth's core. The deep sea is also home to the ghosts of the abyss, creatures so ethereal and otherworldly that they seem to belong to another dimension. The vampire squid, with its dark webbed cloak and bioluminescent eyes, is one such. It survives by consuming marine snow, a mix of organic debris that falls from the ocean's upper layers, using its unique filament to ensnare particles of food in the deep. Another spectral presence is the ghostly jellyfish, floating silently through the dark waters. With its transparent body and delicate trailing tentacles, it embodies the haunting beauty of the deep sea's inhabitants. These jellies, along with countless other luminescent organisms, contribute to the eerie, otherworldly glow that punctuates the ocean's darkness, a phenomenon that remains largely a mystery to those who dwell on the surface. The existence of these giants and ghosts underscores the incredible adaptability and diversity of life in the deep sea. These creatures have evolved to not only withstand the crushing pressures, freezing temperatures, and total darkness, but to thrive in these conditions. They represent the pinnacle of evolutionary innovation, having developed unique physiological and biochemical strategies to survive in one of Earth's most extreme environments. Exploring the depths and studying these creatures offers not only the thrill of discovery, but also insights into the resilience of life, the interconnectedness of Earth's ecosystems, and the potential for life in extreme environments beyond our planet. The giants and ghosts of the deep sea remind us that our planet holds mysteries as profound and awe-inspiring as those found in the farthest reaches of space, waiting in the silent darkness to be discovered. Delving into the abyssal depths of the ocean to uncover its secrets presents a formidable challenge, akin to exploring another planet within our own Earth. The deep sea, with its extreme conditions of high pressure, near freezing temperatures, and utter darkness, creates a hostile environment for human exploration. The pressure in these depths can crush conventional submersible hulls like aluminum cans, and the absence of light renders traditional navigation and observation methods nearly useless. Despite these obstacles, the allure of discovering the unknown drives scientists and explorers to develop innovative technologies and methods to peer into the abyss. The exploration of the deep sea is a relatively recent endeavor, with significant advances occurring in just the past few decades. Traditional manned submersibles, while providing invaluable insights and breakthrough discoveries, are limited by their operational depth and duration underwater. These vessels must contend with immense pressures that increase with depth, requiring thick hulls made of specialized materials, which in turn limit their maneuverability and range. Enter the age of remote-operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, which have revolutionized the way we explore the deep sea. These unmanned vehicles, controlled from ships or even from shore, can dive to the ocean's deepest points, transmitting back high-definition images and data that were once beyond our reach. Equipped with robotic arms, they can collect samples of water, sediment, and marine life, allowing for detailed analysis that was previously impossible without direct human intervention. Despite these technological advances, the deep sea remains a largely unexplored frontier. The cost and complexity of deep-sea exploration missions are significant, requiring not just advanced technology, but also ships equipped to deploy these instruments and teams of multidisciplinary scientists to analyze the data. Each dive is a logistical challenge, involving careful planning and coordination to maximize the limited time these vehicles can spend at depth. Moreover, the unpredictable nature of the deep sea itself poses its own set of challenges. Strong undersea currents, unpredictable terrain, and the possibility of encountering uncharted hydrothermal vents or cold seeps make each mission a venture into the unknown. The deep sea is not a static environment, it is dynamic and ever-changing, with conditions that can shift dramatically over short distances and times. Despite these challenges, the drive to explore the deep sea is fueled by the promise of discovery. Each mission has the potential to uncover new species, reveal unknown ecosystems, and provide insights into the geological processes that shape our planet. The development of new technologies, such as high-pressure tolerant cameras and sensors, and innovations in materials science, are expanding the boundaries of what is possible in deep-sea exploration. The challenge of exploring the deep sea is not just a technical or scientific endeavor, it is a reminder of the human spirit's insatiable curiosity. It pushes the limits of our technology, ingenuity, and determination, reminding us that there are still vast parts of our own planet that remain to be discovered and understood. As we continue to push these boundaries, the deep sea promises to yield secrets that could transform our understanding of life on Earth and beyond. The endeavor to explore the deep sea is not merely a journey through the planet's last uncharted territories, it is a voyage of biological discovery that continually reshapes our understanding of life's diversity and resilience. Each expedition to the abyss reveals new life forms, each more bizarre and fascinating than the last, expanding the boundaries of what we consider possible for life on Earth. These new discoveries often defy conventional biological categories, pushing the limits of our scientific knowledge. The deep sea, with its extreme conditions, has fostered the evolution of organisms with extraordinary adaptations. From fish with antifreeze proteins in their blood to survive near freezing temperatures, to microbes that thrive in the scalding waters of hydrothermal vents, these life forms reveal the incredible versatility of life. Among the most remarkable discoveries are species such as the Dumbo octopus, named for its ear-like fins that resemble the Disney character. These gentle creatures hover in the deep, propelled by their unique fins, far removed from human eyes. Then there's the snailfish, discovered at depths exceeding 8,000 meters, setting records for the deepest living fish. Its body is soft and translucent, adapted to withstand the crushing pressure of the abyss, without the rigid skeletal structure that would be pulverized under such extreme conditions. These expeditions have also unveiled ecosystems that operate entirely independently of sunlight, such as those surrounding hydrothermal vents. Here, chemosynthetic bacteria form the base of the food chain, converting the Earth's chemical soup into organic matter. This discovery alone has profound implications, suggesting that life can sustain itself in the absence of sunlight, a notion that broadens our perspective on the potential for life on other planets. The process of discovering new life forms in the deep sea is fraught with challenges and uncertainties. The creatures that inhabit these depths are often elusive, fleeting shadows that escape detection, living in environments that are difficult to access and even harder to study. The collection of specimens for study requires precision and care to ensure their survival under the dramatically different conditions at the surface. Moreover, the identification and classification of these creatures demand a multidisciplinary approach, combining taxonomy, genetics, and ecology to understand their place in the tree of life. Each new species provides a piece of the puzzle, offering insights into evolutionary history and the ecological dynamics of the deep sea. The continuous unveiling of new life forms in the deep sea serves as a powerful reminder of the vast unknown that still exists on our own planet. It challenges our preconceptions about the limits of life and the diversity of living organisms. These discoveries underscore the importance of exploring and preserving these last frontiers, as they hold keys to understanding not only the origins and resilience of life on Earth, but also the possibilities of life beyond our planet. As technology advances and we dive deeper and more frequently into the abyss, we can expect to uncover even more of these hidden wonders. Each discovery not only adds to our knowledge of the deep sea, but also ignites the human imagination, reminding us of the endless mysteries waiting to be discovered in the dark corners of our planet. The deep sea, Earth's final frontier, is not immune to the impacts of human activity, despite its remoteness and the challenges it presents for exploration. As our understanding of this mysterious domain grows, so does our recognition of its significance to the planet's health and the urgent need for its conservation. The abyssal plains, trench ecosystems, and hydrothermal vent communities are under increasing threat from human activities such as deep-sea mining, overfishing, and pollution. These activities not only endanger the unique species that inhabit these depths, but also threaten the ecological services they provide, which are vital to the health of the planet as a whole. Deep-sea mining, in particular, poses a significant threat to these fragile ecosystems. The seabed is rich in minerals and rare earth elements, driven by the same geological processes that fuel life around hydrothermal vents. As terrestrial resources become scarcer and the demand for these materials grows, the allure of the deep sea's wealth becomes harder to ignore. However, mining operations can devastate deep-sea habitats, plumes of sediment can smother life, and the noise and light pollution can disrupt the behaviors of deep-sea organisms. The slow growth rates and low reproductive rates of many deep-sea species mean that recovery from such disturbances can take decades, if not centuries, making the impacts of mining potentially irreversible. Overfishing is another critical threat. The deep sea is home to species like the orange roughy, which are targeted by fisheries for their commercial value. These species, which can live for over a century, have slow reproductive rates, making them highly vulnerable to overexploitation. The removal of these species can have cascading effects on deep-sea ecosystems, disrupting the delicate balance of these complex food webs. Pollution, too, finds its way into the deep, with plastics and chemicals sinking from the surface to litter the ocean floor. These pollutants can be ingested by deep-sea organisms, introducing toxins into the deep-sea food web and potentially affecting species far removed from human contact. The resilience of deep-sea ecosystems to these pollutants is poorly understood, raising concerns about long-term impacts on biodiversity and ecosystem health. The conservation of the deep sea presents unique challenges. Its vastness and inaccessibility make monitoring and enforcement of conservation measures difficult. Moreover, the deep sea crosses international boundaries, requiring global cooperation to manage its resources sustainably. Marine Protected Areas (MPAs) have been proposed as a way to protect key habitats and biodiversity hotspots in the deep sea. These MPAs, along with international agreements on sustainable fishing practices and regulations on deep-sea mining, are critical steps toward the conservation of these ecosystems. Scientific research plays a crucial role in conservation efforts, providing the data necessary to inform policy and management decisions. By understanding the ecological roles of deep-sea species and their responses to human-induced stressors, scientists can help guide conservation strategies that preserve the integrity of these ecosystems. The conservation of the deep sea is not just about protecting the unknown, it's about preserving the health of the entire planet. The deep sea plays a crucial role in carbon sequestration, nutrient cycling, and supporting the biodiversity that maintains the ocean's health. Protecting these deep-sea ecosystems ensures the resilience of the ocean and, by extension, the Earth's climate and biosphere. In conclusion, as we continue to explore and unveil the mysteries of the deep sea, our responsibility to protect this final frontier becomes increasingly evident. Through international collaboration, sustainable management, and continued scientific research, we can ensure that the deep sea remains a place of wonder and discovery for generations to come, safeguarding its mysteries and the ecological services it provides.